Hi everyone. So in this video, we're going to learn about lists. We'll look at what a list is and see how it compares to all the other variable types that we've learned about. And then look at a couple different ways to use lists, putting things in them, getting things out of them, and looping over them with the loops that we just learned about before. We'll then also see how this idea of a list can generalize to let us store even more complex data if we have groups of things and we needed to access them. So to get us started off, I want to talk a little bit about just what a list is. So previously, we've learned about a bunch of different data types. And all of these types, whatever it was, whether it was a string of text or a number or a Boolean, we were able to store that into a variable. And the analogy that we used for this was that a variable is sort of like a box. I stick a label on the box, that's the variable name, and then I can store stuff into it with an equal sign, get stuff out of it by putting it in an expression. And that was pretty effective at modeling a lot of types of information that we have. But where that starts to break down is when we have multiple pieces of information that somehow fit together. So a great example of this, let's say I have a calendar and I have blocks of time at 9 a.m., 10 a.m., 11 a.m. I might want to store whether there's a meeting in each of these different blocks of time. I could create 8 different variables, 12 different variables for each hour that I'm available and store things into them. But that would be really ineffective. If I wanted to do something like go print out a summary of all my meetings for the day, I'd have to remember the name of 12 different unrelated variables. And a lot of the time, when I wanted to access them, what I'd really want to access is everything in the group. So I would have to repeat the same instructions, maybe by writing them out 12 times, copy pasting. If you hear that concept of repetition, you hear that something's happening more than once, immediately you should be reaching for, this is why we have lists. This is what it is that, or loops. This is why we have loops, and what a loop is good at expressing is repeated instructions. There's a problem though, which is that with our separate unrelated variables, there's no real way to write a loop where we can number these things and go through them in order. There's no notion of what order normal variables are in. So we can't refer to them inside the loop. If I were saying loop over range in 0 to 10 or 0 to 12, those numbers that I get, the 0, 1, 2, 3, 4, can't attach to anything with my differently named things. And so that right there is where lists are going to fit in. A list is a special type of variable that holds a whole group of expressions. It doesn't just hold one number or one string. Instead, it holds 5, 6, 12, 100 strings that are all the same type of data, and then it gives each one of these a numeric index that we can use to refer to the first thing in our list, the 10th thing in our list, the 100th thing in our list. And that'll give us a way to access this data that I could use in a loop with numbers, or that I could use to refer to the whole thing just so I can pass around this one variable instead of 100. So to extend our box analogy from before, if a normal variable is like a box that we put stuff in, a list is sort of like a row of lockers, where we might refer to that entire row of lockers, say, oh, they're the lockers in that hallway. They kind of all have one name. And then each of these lockers gives us the same amount of space, and normally we'll number them sequentially. You'll see locker 1001, 1002, 1003, all side by side in this row. And that's how I like to think of a list, is it's like these slots, whether they're lockers or cubby holes or whatever analogy you want, a drawer you pull out, that are going to allow us to store things numerically, side by side, nice, compact together. So that is the idea of a list. So let's look now at some of the syntax we use to work with lists. So in almost every programming language, the way that we denote a list, the way we say this thing is a list, is with square brackets. When we're first assigning a list, the square brackets get used to hold all of the items. So let's say I was storing all of the grades I got in a class. I could say my variable grades equals, and then instead of just putting one number on the right, I actually put that opening square bracket. And then each item that's part of that list gets separated by a comma. So if this was a list of numbers, I could say 99, comma, 87, comma, 92. When I get to the last thing in the list, I can put a closing square bracket, and that tells the computer that all of these numbers are part of a group, and I want to store that whole group into this variable here. If we were talking about our lockers, our visual representation, it'd be like we had these blocks side by side, and the thing stored in grades is this entire block collection. The blocks are still segmented, so there is 99 stored in the first slot, 87 in the second slot, 92 in the third slot. But this thing can move around as a group. When we're assigning a list, it is perfectly all right if there's nothing in the list yet. It is okay for you to say grades equals opening square bracket, closing square bracket, right next to each other touching. There will be nothing in your list, but that is still a valid list. It is an empty list. And that's useful if we have to build this up over time. Maybe if each item comes from the user or comes from a file we haven't read yet. So that is how we declare one of these lists and say it exists. If we want to use one of these lists, we use square brackets again, but they change meaning a little bit. If we want to fetch something out of the list, access a value that's already there, the way that we do that is we put the name of our variable, like any other expression we've used, any other time we've used variables, but right after the name, we put square brackets and then the number of the position we want. So if I wanted to get out this grade here, we stored that in the slot that's numbered number 1. So my second test, I can get it by equaling to grades square brackets 1. And that will fetch out just that single value. If I just put the word grades here by itself, I'd be talking about the whole group. I need some additional piece of information to be able to put in and take out things as we did with our other variables. And that is, where in this group are we talking about? Saving things into the list or overwriting things already there is going to work exactly the same, but we put the array variable, our list variable name here on the left side of the equals. I could say grades square brackets 3 equals 100, and that would store this 100 in the 4th slot of the list. So when we are creating this, when the square brackets appear by themselves, they're telling us about what goes in the list. Here are the items that are part of the group. When the square brackets are touching the name of the list, we're saying go to this place in the list. It's easy to get those two confused. They are two different uses of square brackets that Python and most programming languages use. So there are two little notes that I want to highlight here. The first is, if you notice, there's something a little bit weird going on with the numbering here. I said the second test is grades at index 1. So second, but 1. The reason that there's that offset there, the reason they don't line up, is that with lists, we start counting from the number 0. The first slot is slot number 0. The next slot is slot 1. The third is 2. The fourth is 3. The fifth is 4. The reason why comes down to the math a computer has to do when it wants to fetch out this thing in this position. Turns out the math works just a little bit nicer if we start from 0. It knows where to find your things a little bit quicker if we do it that way. So that's the convention that most programming languages will use. Not everyone out there. There are a couple that use one. But for Python, lists will be indexed at 0 as the first position. So that is something important to keep in mind. You don't want to be off by 1 because that can be a really hard mistake to find. The other thing I want to note is that it is very typical for each thing in our list to be the same type of thing. This is a mistake I see new programmers make all the time. Notice in our grades here, all of these grades are numbers. And not only are they all numbers, they're all numbers that have the same use. I'm not mixing grade numbers with student ID numbers with class hour start time numbers. Each one of these things in this list is interchangeable. And that's an important feature of being a list. If you have a list of numbers, those numbers should all mean the same thing. If you've got a list of strings, say the names of the students in the class, then everything in that list will be a string. You don't want to mix and match the items of your list. And that is because you might not always know which item you're talking about when you write a piece of code. Here in our examples here, we've got simple examples where I say grades at index 1, square brackets 1. But remember, anywhere that I can put a literal number, like the number 1 here, I could also put a variable that gets evaluated. So I could say, input, hey user, enter me a number, and then I'll get back some number from the user. Say I store it in a variable x, cast it to an int, use parse int, and now I've got a number x. I could say grades, square brackets, x. If some of the things in my list are numbers, and some are strings, and some are booleans, then there's not much I'd really be able to do with the item that I got back then. I wouldn't be able to say my thing and true. I wouldn't be able to say my thing plus 1, because what if it was a boolean? I wouldn't be able to say concatenate this to some other text, because what if it's a number or a boolean? I don't know which type of thing it is, so I can't do anything with it. And that's why it is generally a really good practice when you're working with a list to stick to one type. Pick what type of thing and what meaning for each one of these things is going to be consistent throughout the list, because it will make it way easier to work with this when you don't know what you have, or when you want to do something to each thing one at a time. Which brings us to our next topic, which will be how to do exactly that. So if I want to change each thing in a list, say I've got my list of grades again, and I, as the teacher, decide, you know what? Scores were a little low. I want to scale the scores, add +5 to everyone's score. What I could not do is say grades equal grades +5. That's what we did in our simple variables, and that worked well enough for that. But with a list, if I want to change the things in the list, I need to do so sequentially. Our big way to access the items of the list, to actually change them or look at them, was with those square brackets where we say, here is the one thing I want to talk about. So if you want to change everything, you have to change just the first thing, then just the second thing, then just the third thing, and repeat that over and over until you've done it for everything. That's going to be the big trick of working with lists, is whenever you work with lists, you'll have to think about changes to the group, how you would write that as changes to single things. But in terms of the way we will write that in our programs, once again, we hear a situation where I want to repeat the same instructions again and again. That's exactly what a loop is for. In the case of our list, we can actually use our numeric indices with the loops that we've already learned. In particular, the for loop. So whenever we have a list, there's a function called len. It's the same len that we can use with strings to tell you how many letters are in the string. With lists, it tells you how many items are in that list. So if I called len on this grades variable here after I assigned it, it would give me back the number 3. So when I'm writing my loop, if I want to access each one of these items in this list one at a time, I need the first time my loop runs the value to be 0. Then the next time 1. Then the next time 2. So each thing up to the number 3. Well, it turns out we already saw how you do that. You do that with the range function. You give range a stopping point and it will loop from 0 up to that number, not including it. So if I did range of lengths of grades, it's going to go 0 on the first pass, 1 on the second pass, 2 on the next pass, and that gives me some number that will count up through each slot of my array, my list. Arrays are another name for lists used in other languages. At our level, they mean basically exactly the same thing. So if you hear me slip up, it's a synonym. It's another word for this same data type. The way that my list would look here, or my loop would be for I in range of the length of grades. And then this if I want to actually work with the items in the array, I can use that as my index inside my square brackets and say grades at I. Grades, square bracket I. If I were adding 5 points, I could add on those 5 points, save them back into grades at I. And that's going to go through each thing in my list and make this same change to all of them. And that's all there is to it. That is how we make changes to entire lists. This is such a common pattern that most languages do give us a special flavor of for loop just for this. And that is what's called the for each loop, or in Python and a couple other languages like JavaScript, sometimes the for ... in loop. And the way that that looks in Python is for the next thing in my list directly. So for next grade in grades, I could print out that next grade. And what this would do is it kind of collapses this line and the start of this line where we have to do grades at I. It assigns into this variable the first item of the list and then the second item of the list. So the first time this loop ran, next grade would be 99. And then the following time, it would be 87. The final time, it would be 92. It gets us directly to the values instead of using the indexes to get to the value. So there is one important note about this. This is a really convenient shortcut, but it only works when we're just reading the values. remember, we had said it's getting me the thing that was in there, but it's not actually getting us the thing itself. When we assign something, which is what this is, next grade is being assigned a value, we evaluate it and then take a copy. We had seen examples of this back with simple variables. If I did y equals x plus 4, and then I change x, y doesn't update. In the same way, if I changed next grade here, the original list would not update. The original list is not related to these copies that I get in the loop. So if you do need to modify your list, you have to use the classic for loop with the numeric indices. You'll have to manually access your list one item at a time if you want to make a permanent change to the contents of the list. But if you're just reading it out, doing something like printing or doing something that just requires you to reference the value, then the for in or for each loop is a really convenient way to do that. But this shows you two different ways that we can apply changes to an entire list, one item at a time. So the last thing I want to look at is what to do when we've got more complicated data. So in this first example here, grades, we have a nice flat group of things. There's these grades and they're all truly interchangeable. Sometimes, however, we might have subgroupings. Say I'm writing a program to be a grade book for an entire class. Well, now I have a bunch of grades and they're all still the same type of thing, but they're sort of sorted into categories. I've got the grades for student 1, the grades for student 2, the grades for student 3, and I might want to keep those separate. So the way that I could express something like that is with a nested list. So when I've got subgroupings, the way that I would write that out is I would say my class grades equals, and then I would still create a square bracket to start a list. But inside that list, each item is going to be an entire additional list. So item 1 of class grades is a list with those 3 grades from before. After the entire list closes, there's a comma, and then a whole second list with the second student's grades, and then the third student's grades. If I do this, then anytime I work with this list, I actually need to provide it 2 different indices. First, I need to tell it which one of these items in class grades am I looking at. Then I need to tell it which item in class grades inner collection am I looking at. So if I wanted the first student's third test, I would say class grades square bracket 0 to get me to here, and then immediately after that, square bracket 2 to get me to their third test. If you look at this, when Python evaluates this, it's almost working inside out. It's going to say, start here, can I find this list? And then look at this entire thing, class grades of 0, get me that list, and that's the first step of evaluation. Then once it's got that thing, it's going to say, okay, now that thing, square brackets 2, in here go to the 2 thing, and that would work for however many layers we've got. Say I've got, well, my full grade book is a list of courses, and those courses are each a list of students, and those students are each a list of grades. And then say, oh, well, the whole college is a list of professors, and each professor has their list of courses, and each course has the list of students. We could make as many nested lists as we want, and it's just every time we accessed a single grade, we would need to provide one more number in that chain. If we're going to work with a loop with a list of lists, then the way that we do that is we actually put the 2 loops inside of each other. So the first loop would say for the student in class grades. And then the first instruction of that indented inside the loop would be for grade in student, the thing that we just fetched out on the left side of the in on the line above. When we looped over this, the way that this would work is it would loop, the outside loop would run the first time and fetch us this whole list. Then the inside loop would run 3 times, once for each of these grades in here. Once we got to the end of that inner loop, it jumps back to the outer one and it repeats for this second one here. We actually go whole person by person, whole list by list when we want to process higher dimensional data like this. But otherwise, all the rules still work exactly the same as our simple lists. So I show you this to show you how powerful lists are, but keep in mind, it is relatively rare that you need to create a list like this. Maybe once in every 50 programs you write, you realize you've got groups of groups. 90% of the time, it is way more than enough to just say, here's my collection, here's the list of things in it. I can fetch things out, put things in, or even loop over it with a for loop or a for in loop. That is generally what you're going to need. This list of lists extension is just great when we've got something more tabular in a table like a spreadsheet. Say we've got columns and rows and we want to record each entry. That is where this list of lists will come in. The only other thing to think about with lists, the only other thing to look at if you're eager to learn more, would be that there are a lot of functions attached to lists. In the same way that strings have dot functions that help you do a lot of helpful, useful, common things with strings, lists have the same thing going on. There are several dot functions that it's worth looking up in your language documentation, in the Python docs for us. They work just like any other function, so it would be a waste of your time in this video for me to read them out to you. You can read more quickly than I can speak, especially because I'd be showing you graphics and everything. But that is something worth looking at because that does give you a lot of useful tools to do things like reverse the order of the list or filter the list to certain values. There's sometimes a function that can act as a shortcut for you. But otherwise, that's everything I've got to introduce lists. In the next video, we'll be looking at another type of collection, dictionaries, and how they let us store things in groups in a slightly different way. So look forward to that, but otherwise I'll catch you all in the next one.